Off to the next area of the auto sampler. Who would have ever thought that this many pieces and parts would be inside of an auto sampler for me to maintain and fix and take care of and nestle like a little bitty baby to make sure that the HPLC stay happy? All right, so we are now going to focus on the rotor seal and the stator face. What is a rotor seal and a stator face? All right, well, in the last videos, we've described the injection valve. We're like, hey, this is the injection valve and this is how much it costs, thousands of dollars. And then on the front of the injection valve, we see 1, 2, 3, 4, 5, 6, and it went this way. So we're like, hey, this is where all the tubing lines go to, blah, 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 and 3 stays open. All right, so we are going to be focused on behind that stainless steel cover. So that stainless steel cover, as you can imagine, can be taken off. If all of the tubing lines go in there, that means all the liquids go in there. And that means if those liquids go in there, things can get slimy, things can get moldy, things can set up crystals. Things can begin to give us a problem, so we need to go in and clean it out. So once more, here's a schematic of the auto sampler, and we are focused on the 6-port injection valve. So we talked about the HPLC containers, check, and then we talked about the auto sampler trays, check, and then we talked about the needle seat, check, and then we talked about the needle, check, and then we talked about the needle drive, check, and then we talked about the analytical head, check, and then we talked about all the tubing lines that go in and out all over the place, and we talked about the pistons inside the analytical head, check, and then we talked about the seals in the analytical head, check, and then we said, hey, here's spot 1, 2, 3, 4, 5, 6, and this is where all the tubing lines go, and this is what it does, and this is what it carries, check, 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 check. Now we're going to be talking about behind that stainless steel cover. So again, who would have ever thought? But folks, this is how much maintenance needs to go into just one of the modules of an LC system. All right, so this is the front cover of that injection valve. So that stainless steel piece has a name. When I take the stainless steel piece off, I'm then going to find something that looks like this. All right, so we need to talk about this. This is not going to be the only time that you will see this. This is going to be commonly found in HPLC, and it can also be found in IC as well. In the IC systems, well, this is a liquid chromatography system. So ICs are no different. It is liquid mobile phase, liquid samples. They go through 6-port injection valves. All of it is the same. So if you know what the HPLC injection valve is doing behind that stainless steel cover, then you will know what this kind of piece is doing as well, and how to go through and maintenance or clean it, or just simply order a new one because you can't clean it and you're going to replace it and kind of start it all over again. All right, so we've got what you see on the screen, a stator head and a stator face. So we are going to define this in just a minute. I've not really preferably named them. I'm just calling them right now the stainless steel piece and then this plastic looking piece. That is it. So these issues are going to be basically because of this plastic piece that's down here at the very bottom. No maintenance really is going to be done with that stainless steel. That is just an area that our little thumb screws are going to be connected to. Our tubing lines are going to be connected to that. And that is it. So that area is just kind of the front facing cover of this entire injection system. And then what's behind that is really what's seeing all of the fluids and all of the samples. And if you look here, look at that. On this plastic piece, there's like a little bitty tiny hole, 1, and then 2, and then 3, and then 4, and then 5, and then, oh my God, there's 6 little tiny holes. Well, guess what? There's 6 port entries and exits. That's part of the injection valve. That is where eventually these little solutions are going to go into, in those little super tiny little bitty holes. Now you understand why there can be a problem in the injection valve, because those little tiny little bitty holes can easily get clogged up. So wear and tear, 30,000 injections, folks, that these things can normally have before you go through the motion of probably needing a new one. So these are very durable. These are working great in a real lab situation. As long as I'm making effort to keep them clean, that's all that matters. Now, over 30,000 injections, normal routine maintenance will say, get rid of that piece and replace it with a new one. So we'll talk about about how to do that. And it's not actually a very difficult job, but we'll talk about how to do it. And some people will do it less than 30,000 injections. That's okay, especially if clogs get in here and you can't really get them cleaned out. So the reason that you would replace this, or the reason that you would do maintenance behind that stainless steel plate, is that your pressures are skyrocketingly high. If your pressures are high, that means a clog is in the system somewhere. And it seems like all of the other pieces and parts can cause high pressure, and this can too. So again, it is trial and error. But this can also create low pressures at the same time, because if there are leaks that are happening around this injection site, then stuff is leaking out, stuff is not getting pumped through, and that can pop a leak and our pressure begins to plummet. Of course, leaks can be an issue. So if I start to see leaks around the 6-port injector, I know that I have a problem. I know that I have an issue. And again, poor precision. So if I have a really low relative standard deviation, cha-ching, cha-ching, that's where it's at. That's what I want. So if I have a really high percent RSD, that means my standard deviation is also extremely high. My machine can do much better than that, so I don't want really high RSDs. Now, that injection is going to be based on a number of different areas, not just this plastic piece that I've circled, but a number of different issues otherwise everywhere else. And any of those could contribute to that, absolutely, but it could be this. All right, so this is how I go in and replace that plastic piece, and we're also going to start labeling it with the proper terms, so that way you know what we're talking about. All right, so step number 1, it says remove all the capillary fittings from the injection valve. All right, so if you look, I've highlighted that already. There are no tubing lines that are going into any of these actual entry points or exit points of the injection valve. So I've taken a screwdriver, I've loosened up all of those screws, and then probably use my fingers to keep twisting and remove all of the tubing lines out of the way. I need those gone. All right. So that way we can get in here and take out this injection assembly. Number 2, it says now loosen the bolts that hold this into place. So if you look, there's a bolt that is right there, and there's a bolt that's here, and there's a bolt that there. Rule of thumb is you work at them little bits at a time. So I'm going to take my Allen wrench, and I'm going to go in, and I'm going to loosen this up and give it a few turns, and then move either clockwise or counterclockwise, it does not matter, and then take the Allen wrench and loosen that up 2 or 3 turns, and then loosen that one up 2 or 3 turns. That way you don't put weird stress by having this thing go crooked. The last thing that you want is for 1 or 2 screws to have a lot of pressure and the other screw to be fully removed, because this puts warping into consideration, and I don't want that. I don't want that stress unevenly distributed around that injection valve. So work on those screws little bits at a time and work yourself around and keep going around and around and around until those screws are fully removed. So we're going to remove all of those screws, and we're going to remove them fully. Next piece, we are going to remove the straighter head. So the straighter head, the head is at the top, right? So the head is what is facing you here on the stainless steel piece. So if I go back to this picture, this piece that we've been calling the stainless steel piece, this is the head. And the reason we call it the head is because that is what I see first. Just like your head, I see your head first. And then behind the head, there is the face. So that plastic piece that we circled in that same picture, this is going to be the straighter face. So I've got the analytical head that I'm going to take, and I set it off to the side. I probably don't need to do anything with that. And then I'm going to take my straighter face, and this is probably the issue that is clogged, or that needs to be replaced, or that I need to do some work on. So let's say that I'm just going to replace it. Not a big deal. I'm going to take the old one and I'm going to trash it. Then I'm going to take the new one, and the new one has these 3 little pegs that I've highlighted in step number 4. those three little pegs are going to line up with the straighter head, because on the back side of the straighter head, there's three little holes. And those three little holes need to perfectly match the straighter face. And the reason for that is because those holes are supposed to see certain lines. And I need to ensure that those little tiny holes of the straighter face is lined up with the proper ports of the straighter head. And that's the way the manufacturers are going to do that for you. So those little pegs are there for a reason. Those pegs are going to sit in place in a proper location, in the right location, so that way you ensure that everything is lined up and that the entry and exit ports are the proper entry and exit ports that you should be using when you apply the new straighter head on there. As you can imagine, these are not numbered. So how would you know which one goes where? And if those pegs were not present, this thing can turn and turn and turn and turn, and you can line this thing up any way that you want to line it up, and you would not know any different. So those pegs are very important. So do not try to break them off. They are there for a reason. I know that sounds crazy, but I swear, if I don't say it, somebody's going to try it. And then those pegs are going to seat that face in the head at the proper location. So when I apply the new one, that's not a big deal. I'm then going to put the whole thing back in place. And then just as before in step 5, I'm going to work these screws in, and I'm going to take my Allen wrench or my hex wrench, and I'm going to turn, and then I go to the next one, 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 then I go to the next one, and I keep moving around and around and around and around to make sure that those are not experiencing any type of extra stress that they should not be seeing. And then in step number 6, it's going to say, all right, now the dreaded piece, all of the connections need to go back into that injection port. So in spot 1 and spot 2 and spot 4 and spot 5 and spot 6, all of those need to be connected in the proper way. And if you need help, guess what? There's the sticker, and that sticker tells me what line needs to go where into what port number, so that way if I forget Tracy's lecture assignments from years down the road, then I'll know and I have a point of reference on how I need to start plumbing the LC system to make sure the injection port is working properly. Next up, the straighter face. The stator head. The stator head for an Agilent 1100 or something similar is also equivalent to the 1200 series. Anything that can withhold pressure to 400 bar. Look at this price, $3,248. Oh my God. So this is why we often say, please do not strip. Do not over tighten those screws, because if you do strip them, I know it's metal, I know it's stainless steel. This is going to be an issue if you're not very careful. You can strip and you can damage the actual head. If you do that, that's bad news bears, because again, that's over $3,000 for a part. Now, it's easy to replace. The only thing I got to do is just get the new one, put it on for the old one. I mean, there's no issues here at all, but this is very expensive. So this is why we often say finger tighten first. And then when you finger tighten, you're going to take that wrench and you're going to go like a quarter of a turn, and that will seat it in position. If you get a leak, then go in and tighten it up a little bit maybe. But do not over tighten these screws, because when you do, you have the chance of stripping it just like anything else if you were assembling furniture or something at home. Now, this should not be damaged over a course of time. This is going to last almost for the lifetime of the machine unless it is mistreated or mishandled in some form or in fashion. Now, the stator face is a little different. This is what's going to get clogged. This is what's going to cause an issue if you're not very careful. And again, look at the little teeny weeny little bitty little baby bikinis. No, look at the little teeny holes. Those little tiny holes can get easily clogged and get stuff in them. So we can clean them or we can replace them. If we're going to replace it, that's going to be $350. That's shot down their way. Now, if we can clean it, then this is going to be free. It's just a little bit of methanol or a little bit of proper solvent that we need to use, but it's still going to save a $350 replacement piece. So the stator faces, again, make sure that you are ordering the proper ones for your pressurized systems. This pressurized system might be a little bit different than the ones that you are using when you get a job and when you start to maintain or maintenance them. And if so, that's okay. Just make sure you get the right ones. But this $350 piece can be switched out with a new one, and you don't have to clean. You don't have to wait. Your run time is going to be minimized, so that way you can get this system back up and running quickly. Now, we are going to talk about cleaning them, absolutely, but we're going to save that here in just a minute, all right? Next up are rotor seals. Rotor seals are part of the injection valve as well, so sometimes the seals have to be replaced, not just the stator faces. So this is the stator face. That stator face does need maintenance. That stator face does need to be replaced or cleaned. And then behind the stator face, there's actually other pieces of that 6-port injection valve that's going to kind of do the turning left and right and do whatever it needs to do. And that is a rotor seal. So we need to kind of talk about the rotor seals and where those are located and how to replace those as well. Just as before, the same old story with just a different piece and part. If your pressure is high, it could be due to the rotor seal, not anything else that we've talked about. If the pressure is low, it could be due to the rotor seal, not anything else that we talked about. If you have leaks, it could be due in the injection port. It could be due to the rotor seal, not anything else that we talked about. And then poor precision is also going to be a result of a nasty, trashy rotor seal. So again, like I've been saying the whole time, folks, this is trial and error. It is a way that we go in, replace pieces and parts, and kind of look and see what's going on and use some common sense. What do things look like? Where are leaks happening? If I unloosen this tubing line, does my pressure go down? Does my pressure build up? What's going on? So again, common sense goes a really long way. But this is what we would say the leading injection of a valve problem. That's going to be probably a test and a Canvas question. So it's actually not the stator head that's going to be the most common. It's actually not the stator face with those little bitty tiny little witty little holes. It's going to be the seals themselves. So the seal is very often going to have to be replaced. Wear and tear is going to happen here. As you can imagine, there is a valve in the injection port. That valve turns left, right, left, right, left, right, left, right, left, right, left, right, left, right. And if it does this all day, every day for hours at a time, you can kind of imagine that this thing is going to wear itself out. And then when it does wear itself out, then it does not become leak-free anymore. And guess what? It doesn't seal even though it's called the seal. And then we get little drip, 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 drip. That begins to happen out here. So replacing the rotor seal, very easy, similar to the stator faces. I'm going to disconnect all the tubing lines for the stator head. Number 2, I'm going to loosen the bolts, and I do this and I work clockwise or counterclockwise, little bits at a time, until those screws can fully be removed from the stator head. Then in the next directions, I'm going to take the head and I separate it off. I then take the face that is here. I look at it because I'm already in the weeds. So I begin to look at it. I'm like, hey, maybe this could use a little bit of cleaning. So I might soak it in a little bit of solvent. I might sonicate it in a little bit of solvent. Maybe it doesn't need to be replaced, and that's okay. No one says it has to. That's not the intention here anyway. But while I'm there, I might as well go through the motions of just being preemptive about the problems. And then finally, there is a stator ring that we really didn't talk about previously. So there is a ring here on the back side, and that ring just going to basically be pulled off. So when the ring gets pulled off, there is the rotor seal and there is an isolation seal that happens there. So this issue is very easy to get to. If I am already in the mix of the stator faces, I just got to take 1 or 2 extra steps in order to get to the rotor seals. All right, so once I get to the rotor seal, I'm then going to take the new seal and a new oscillation seal. They're often sold together. And then I'm going to just push it back up into the injection valve that rotates and turns. And again, look at the orientation. There's a hole here, a hole there, and a hole there. And there's a prong here, and a prong there, and a prong there. This will only fit in that turning valve one certain way, and that's to help you make sure the orientation is proper. So after the installation of the rotor seal, after the installation of the oscillation seal, then the collar goes back on. And that collar then will allow you to reattach your stator face to your head and then sandwich it all back together again with the Allen wrench and the screws that go back together. Again, you probably have some external videos that show the exchange of a rotor seal on an auto sampler system. So if the pictures don't do justice, then the motion of the videos will. The rotor seals are going to be a little over $100 a piece. This is not going to break the bank. So if you do want to switch them out, if you got $175 or $200 left around, then you might as well go ahead and switch these out too. So if you're taking the injection valve off and you're working on the stator faces and you're replacing the stator faces, then just go ahead and order a new seal and replace the seal while you're in there so you can ensure that you are killing 2 birds with 1 stone. I mean, why go through this whole thing all over again to realize that you should have replaced the rotor seal instead of the stator face because you did not know any better? So might as well replace both while you're in there and doing the maintenance on it to cause you some, to prevent some issues later on in the future. So again, external videos are there. How to replace a rotor seal. Watch it, watch the person in action, and I think that you'll learn a little bit more about the steps that are needed in order to get into those injection valves and do a little bit of maintenance on them. All right. Next up, the next video, we're going to focus on contamination. We are somewhat finished now with pieces and parts of the auto sampler, and now we need to talk about where the contamination is coming from inside of the auto sampler. So we're not done with the auto sampler lecture, but we're somewhat done with all of the pieces and parts, or the main ones that make this auto sampler work the proper way. So in the next video, which is probably going to be our last one, we're going to focus on contamination issues, how to take care of them, what to watch out for, and then things that I can do to be preemptive in stopping a lot of the problems from happening.